Hi everyone, it's Miss Huang here, and we'll be going over position versus time graph practice 1. So the first thing we must do, read the question. Let's see what they're asking us. An object is moving along the x-axis. The graph shows its position from the starting point as a function of time. Various segments of the graph are identified as the letters A, B, C, and D. So again, we're going to be talking about segments, and in some questions you're going to be seeing phases or sections. These are all the same. They're just asking you what are the different movements found on the graph. So that all has to do with motion, and the different parts of this graph equal different motions, okay? And you have to identify each type of motion in your graph. So A, B, C, and D are all different types of motion, and we're going to be explaining those, okay? So let's go over it. A, we see it's a straight diagonal line going upwards, away from the x-axis, okay? Away from the x-axis. And it is also a straight diagonal line, meaning that it's going to be a constant velocity. Constant velocity also means that it's uniform motion, okay? It's uniform, meaning that if you take any of these numbers and plug that into that slope equation, rise over run, you're going to get a slope that is the same number at all these points because of that straight diagonal line. And we're gonna get values that are positive because they're going in that positive direction and it's away from the x-axis. Let's look at B. B is going towards the x-axis into negative values, okay? So that means any value that we calculate for B will be negative, and it's also a straight diagonal line, meaning that any of these points that we take in to plug into the slope equals rise over run equation will give us the same number. Even if we take these 2 points here and plug it in, or take these 2 points here, we're going to get the same values because of that constant velocity. It's uniform. All the points will give you the same number, okay? But this time, it'll be negative velocity because it's going downwards. Let's look at C. Well, C is a straight horizontal line. Straight horizontal line shows us zero velocity, okay? So zero velocity, meaning that the speed didn't increase or decrease at all. You're actually at the same position at -5 throughout this time period. So you can see at 10 seconds, at 15 seconds, at 20 and 25 seconds, you're still at the same position, -5 meters, okay? So you didn't change at all, meaning that you didn't increase your speed or decrease your speed. Let's look at D here. D is that straight diagonal line, and again, it's moving upwards. It's moving in a positive direction, going to positive values. You're getting out of that negative zone. Therefore, when you're going to calculate the slope for D, you're actually going to get a positive slope number, and it is constant because of that straight line, and therefore anywhere you measure or any value that you take from the line of D, you're going to get the same number of slope, okay? Even if you take numbers from here or numbers from here. So let's start answering some of our questions now that we understand this graph. Number 1, during which intervals is the object moving in that negative x direction? Well, we see it. We already talked about it. It's B. Alrighty. Question 2, what is the velocity of the object at 7 seconds? Wow. Okay, let's look at the graph now. 7 seconds is approximately here, 7 seconds, and it's in between 5 seconds and 10 seconds. So we're definitely going to use that for our initial and final times, because these are exact locations and we don't have to go ahead and guess the decimal places if we choose points here or here. And we can do that because this is a straight diagonal line that goes downwards, okay? So we know that a straight line will give us a constant velocity. Any points that we take and plug into that calculator, we're gonna get the same velocity. So might as well make it easier for ourselves by picking definite points that we don't have to guess decimal places. All right, so what is the velocity? Let's bring out that equation. So V, I put an arrow on top to show that it is a vector, and that vectors have that directional quality to it. So V equals the change in D over the change in T. dF minus di. F is final, di is initial displacement. Then we have TF minus TI. So the di, if we look on the graph, our final displacement was at -5. So -5 meters. Practice putting in the units so that you know what units you'll have at the end result. And then di right here is at 10 meters. Over time of TF, we know was 10 seconds because we're picking numbers that are for sure definite and that we don't have to guess the decimal places. 5 is our initial time, 5 seconds. So -5 meters minus 10 meters, you get -15 meters. Divided by 10 seconds minus 5 seconds, you get 5 seconds. So that equals -3. And meters divided by seconds, you get meters per second. So the answer you get is -3 meters per second. Does that make sense? Well, for sure it does, because look at this. You have a negative, which shows that the B slope is sloping towards the x-axis into those negative values. So a negative velocity would make sense. And also, you have a 3 value. Therefore, if we compare any other slope to B, we will see that B has a much steeper slope. Therefore, 3 is going to be our largest value. So if we calculate the slope for D, which we will later on, D has a less steep as a slope, but still horizontal line. So once we calculate the slope for D, we're going to realize that this value should be less than 3. Okay? Let's move on to the next question, which is, what is the average velocity between 10 to 30 seconds? So we're going to be seeing that now. Okay, let's erase some of this here so we don't get confused. So what is the average velocity between 10 and 30 seconds? Okay, average velocity, well, it gives us our final and initial time values that we're going to plug into the formula. We just have to look for df and di. So let's put v, velocity equals that change in d over that change in time, equals df minus di over tf minus ti, and then you get your values from the graph. So df, at the final time here, we're at a position of 0. Okay, 0 meters, minus the initial position was at -5 meters. Over a time final was 30 seconds, it was given to us, minus time initially was at 10 seconds. Minus. So here you see a minus multiplying by this minus value of 5. So this actually changes into an addition, okay? So 0 meters plus 5 meters, you're going to get 5 meters. Over 30 seconds, take away 10 seconds, you're going to get 20 seconds. So 5 divided by 20 gives you a value of 0.25. Meters divided by seconds, you're going to get meters per second. So let's look and see if that makes sense. We'll see most of it, you're not moving. There was no velocity, 0. So if you average 0 velocity to this velocity here, d, which isn't 0, it's a positive velocity that's constant going upwards, and we see that going upwards means it's positive. We did calculate a value that is positive, 0.25, and we also said that 3 from B earlier was much steeper than D for Daniel. Therefore, our value 0.25 is less than the 3, which makes sense. So Therefore, I can say that we calculated just fine, and this is helping you double check your work and your answers. 4. What is the total distance traveled by the car? The total distance is just adding up all the meters, okay? So if we start at line A here, we had 0 meters, and at the end of line A, we have 10 meters. So that's just 10 meters plus, so for distance, remember there is no directional quality to it. Therefore, we can just add all the position differences, okay? So A there. Now B, we were at 10, and then we had another 5 meters, and another 5 meters to end up at negative 5, okay? So 1, 5, 2, 5 equals 10, another 5 equals 15 meters for B. And then at C here, we didn't change positions at all. We were constantly at negative 5 meters. So that means 0 meters for C plus, and right here for D, we noticed that we moved up to 0 meters. So that difference there is 5 meters. So we add 5 meters. And now we add up the entire thing, 10 plus 15 plus 0 plus 5, and you get a total distance of 30 meters. Because again, distance is just the entire thing that object has traveled. What is the total displacement that's traveled by the car? Well, displacement is different because it's the overall position where it ended up, okay? So the overall position of the object, the overall change in position. Change is very important, that word. So let's look at our initial position on the graph. We were at 0 as the initial position, and our final position on the graph, we were still at 0. So that means our change in position overall was 0 meters. So D equals 0 meters. Now 0 is kind of neutral. There is no plus or negative, so we don't have to worry about that directional component. However, if we were at 5 meters as a change in displacement, then we would have to put 5 meters. So a plus 5 meters is just saying that we are east, okay, in our positioning. But since it's 0, we do not have to worry. All right, so that's just what this problem is, or this practice problem is. And if you guys are still stuck, message me on Microsoft Teams. I'll be going over velocity versus time graph practice 1 next. Have a great day, everyone.